component passive cooling system and the condensers and containment internal structures. Then we looked at new and spent fuel storage racks. Review of applicable Tier 1 and Tier 2 information, as well as Part 7 of COLA, the departure and exemption evaluation. We have also performed confirmatory analysis of the seismic input motions, or in other words, when they provide, say, first, represent the first. Now, we really, for a deterministic analysis, we need to develop a time history. So we also made some independent evaluation of that time history, as well as strain-compatible soil profiles, and the SSI analysis for fire water storage complex. We just did in one case with the soil separation, just to see how the results compare. And then, in addition, we also have done the verification and validation of the computer programs that they have used, or we have used in the Nordana, primarily SASE 210, and all the details are presented in the SER, how we did it, and step by step, all those information. So, we also reviewed spent fuel pool, storage racks, and so can you go to the next slide? These are primarily the regulations and guidance that we used. Then I'll go over basically the results of audit, what we found. Now, staff originally reviewed FSAR Rev 7 and 8, and based on that review, we had about 29 RAIs, and these RAIs, the major issues that we identified in these RAIs include consideration in the seismic demand, the effect of potential variation of structural stiffness, potential of separation of soil and the embedded walls, effect of adjacent structures which are known as SSSI, SSSI, location of the control motion for the fire water storage complex SSI analysis. Also, we identified that use of an approximate method for evaluation of the standard design for site-specific demand. And also at the time, we did not have in the FSAR the fuel storage rack evaluation, the PCCS condenser, site-specifics, for site-specific seismic demand, and as well as an updated SMA was not there. So anyway, these were the RAIs that we initiated, and then also in response to these RAIs, we had a number of public meetings, and then the applicant modified its approach to performing certain aspects of the seismic analysis, and they have developed a seismic closure plan. The seismic closure plan included the tasks necessary to address the RAIs with an accompanying schedule. And then a key feature of this closure plan was to provide information to the NRC as soon as it becomes available. And so it was very helpful, because as soon as they're doing it, we can do it, so it saves a lot of time, and issues are identified in a timely manner. So we went that way. And as the Dominion mentioned, that they have done several SSI analysis, like 18 SSI analysis for reactor 12 building, control buildings. They had a slide on that. And then, so can you go to the next page? We have done the review in two phases. The first phase was primarily to develop the seismic demand aspects. Okay, anything to do with developing the seismic demand, which means the loads of the structure, amplified response vector, they are the seismic demand. So we focused primarily on that in phase one. And once phase one was done, we focused on the capacity evaluation, or in other words, where this load had exceeded and what was the magnitude and how it will be resolved, how the design was verified. And the applicant already mentioned mentioned, they used the similar method as DCD, basically same method, and running a finite element to develop the detailed stress checks. So they actually performed a detailed stress checks for the specific seismic demand at the North Anna site. Now, what we found that the standard design is adequate, except few instances where a design change is necessary. The changes include modifying the arrangement of some steel reinforcements, some shear ties, the size of steel girder, weld size, and some anchor bolt sizes, and the related embedments. Important thing is no changes to the thickness of the concrete walls or slabs were required. That's very important because that gives us confidence that the design is okay. We don't have a major change. And in fact,
may I ask a question here then? So my earlier question, I expect that the DCD, the base design, is very robust. And yes, there are different site-specific aspects of this, the seismic demand. So when you say no changes to thickness of concrete walls and slabs were needed, what basis do you had exceedances of loads? You look at the margin that's in the building wall and apply the load against it. And even if there's an exceedance, you say, well, you have sufficient margin.
Yes, basically we have to go through the code, allowable code stresses. Right. So when you do that, there was no need for the changing the thickness, only minor changes in shear ties and some spacing of the shear tie spacing, that kind of change, okay, or some anchor bolt, increasing a little bit on the diameter of the anchor bolt. So that kind of change. In fact, I am very confident that had there been no changes, they didn't do any changes, this structure will perform excellent. My professional experience. But since we are now in a design mode, we should take care of what it is coming, not an evaluation when we are designing really. That's why, any little changes that we can do, we can do. And these are very minor changes.
Yeah, well, having done a lot of code stress analyses in my life, you don't necessarily always go to 0.98% of the limit. Sometimes it comes out to be 50% of the limit or 75% of the limit, and so you increase the load, you're still below the limit, and very often is the case.
Right, and
my point was, it's against code, though, that you make the determination.
Mm-hmm. Yeah, against the code. So next slide. Documented in our ACR that we confirm that the site-specific seismic design method for SSCs is acceptable at the North Anna site with the identified changes. I think it will perform adequately. The site-specific IRS, ISRS is in-structure response spectra that is used for design and analysis of the equipment and components. It has been developed all the places separately, and where necessary, they have taken all the effect of stiffness variation and SSI and all those things. They are there. So, and those curves were developed because we did audit in two audits. Okay, audit one for the demand evaluation, audit two for the capacity evaluation, and we have seen they have, the applicant has developed all those IRS in appropriate locations. Even so, this IRS has exceeded also the CSDRS. So nevertheless, they will now use both, okay, in their qualification. So I do not have any concern. Okay? I think our applicant has done an adequate analysis to justify that, and we have reviewed it, and we find it acceptable.
When you say use both, do you mean envelope both, or do you mean use them both?
No,
each one separate.
They have done the CSDRS already, okay, or they will, for the equipment qualification, they will use the spectra derived from the CSDRS as well as the FIRST. Yeah, they will.
I assume there were some areas where the ISRS didn't exceed the designs.
Yes, there may be some.
In those cases, that didn't require a reevaluation.
Absolutely. Yeah, no question, you don't duplicate your work, right?
If there are no further questions, okay. I'm Jim Gilmer from the Reactor Systems Branch. We'll be discussing the Chapter 4 review. You got the slide for that? Oh, wait a minute. This is fuel storage. You want to talk about the rack? Oh, you want to?
Oh, the rack already presented.
We'll skip the racks?
Yeah, skip that because it's already same thing that Dominion provided.
Understand. Skipping. Okay, sorry. I'm Jim Gilmer from the Reactor Systems Branch of NRO, and have a couple members from the branch help me out with questions if I can't answer. I'll look to the side here. Actually, the first 7 revisions of the COLA, all of Chapter 4 was IBR, incorporated by reference. I believe Revision 7 introduced the Departure 371, which then resulted in site-specific exceedances for both the fuel and control rod due to a few frequencies exceedance. The regulations that we use, of course, the ESBDR rule, Part 52, Appendix E, and the key regulation was General Design Criteria 2, Design Basis for Protection Against Natural Phenomena, which requires demonstration for structures, systems, and components that the safety function can be performed with the combined natural phenomena and hydrodynamic loading. The rest are just the guidance that is applicable. Next slide. I've already given a little bit of that background, but basically the concern that we had is that because of the exceedances we were aware of, we needed information to conclude that the site-specific fuel would remain bounded by the design certified capacities. And the certified design includes a couple of mechanical topical reports, one, I believe 2 for the fuel and 1 for the control rod that documented analyses and testing. The fuel testing was actually done for the GE14 fuel, which is 12-foot length, and it's used in the operating fleet, and the ESBDR fuel is 2 feet shorter, approximately, so would actually be stiffer. So we concluded that the test would be using GE14 fuel would bound the 14E. The hydrodynamic loads portion, which would include LOCA, SRV, chugging, condensation oscillation, etc., is in an approved topical report that is incorporated in the rule for ESBDR. And there's another topical report, NEDE 21175, that provides the methodology. Essentially, the latest revision is a method for calculating the vertical uplift for the fuel. The earlier version has documented the entire methodology. The design cert has a Tier 1 ITAC number 15 for the fuel to ensure that the as-built analysis is completed prior to fuel loading that demonstrates acceptability. Dominion proposed an additional ITAC as part of the COLA for the control routes, a similar analysis and demonstration of the acceptability. Okay, next slide. Okay, the staff confirmed that the methodology used to determine the site-specific fuel accelerations was consistent with the method approved in the DCD. And essentially, what Dominion has done is done the ITAC in advance, except using bounding hydrodynamic loads since the detailed engineering is not complete yet. And that will, of course, be repeated once the detailed engineering is complete. Okay, I talked already about the Tier 1 ITAC and the COLA Part 10 ITAC for the control blades. Okay, next slide. Okay, in conclusion, the staff determined that the site-specific mechanical stresses are bounded by the certified DCD test values, and the control rod stresses, as well as the scram insertion times, remain bounded by the DCD test values. And prior to fuel shipment, the ITAC will be completed to demonstrate that the fuel that's loaded will be acceptable. And finally, our safety evaluation concludes that both the fuel and the control rods are in compliance with the regulations. Any questions?
Jim, so I would assume that all the design and analysis work is done for the fuel elements and the control rods. So what will you confirm when they get ready to ship fuel? You'll do a quality control check on the fuel to see that it meets design specs, or not repeat analysis at that late date, would you?
Well, the part that will be completed prior to fuel load is the hydrodynamic loads. Actually, they're currently using basically frictionless bounding SRV and local loads. So the actual as-built will be actually lower hydrodynamic loads. So we needed to determine now that what actually gets built will be acceptable in order to grant the COL.
Have they tested aerodynamically the short GE14 fuel for pressure drop and CPR, or are they using conservative long fuel correlations? I'm actually not sure what they did on the CPR. I believe though the methodology is the same. They're using basically the G-star method for what's used in the. So they're using the 12-foot tests and assuming that it bounds what is it, 8 foot?
I believe that's the case. We'll have to confirm that.
And second, the staff is giving a license for Northana to operate with GE14E, right?
Right.
So 15 years from now, when they're ready to load, GE will have to retool their machining because they'll be producing GNF5 then, right?
Right. maybe GEH can answer that better, but I assume that...
There's a commitment to find G14E somewhere, right?
Yes.
And then for cycle 2, you put GNF 12.
We have to revise our license to reflect changes and look at that.
Right.
This is Gina Borish from Dominion. Yes, so our license is for the GE14E fuel, and that's what we plan to use. And if we have to get a license amendment at some point, then we will.
That one stays on all the time. Just don't whack it.
Other questions?
Yeah, and this question probably more for Manas. Noteworthy to me by its absence is no reconsideration of the reactor pressure boundary seismic loads. And I'm kind of surprised that the seismic response would affect the fuel, I mean, without affecting the reactor vessel.
Well, the reactor vessel was modeled in the dynamic analysis, but this was a, what we call lump mass model simplified, and fuel was included there too. Fuel as well as the reactor vessel, they are included in the lump mass model.
But there was no increase in the loading, loads on the vessel, or piping connected to the vessel?
We have looked at, from the structure point of view, the support loads, okay, the reactor vessel support loads, and we have looked at them, they are fine, okay? They are within the DCD limits, okay? Now, as far as the reactor coolant system, and we have not looked at that.
So I assume that if the loads had gone up in the reactor coolant system, that we'd have seen a presentation of the results, right?
We didn't review the actual component, like, I don't know here, what kind of things, the reactor vessel, then it will go to the steam line.
Right.
We have not looked at that.
The staff did review this in Chapter 6, and basically it comes down to meeting the ASME code requirements, so at the as-built condition. So that's what when they evaluated in Chapter 6, we actually sent this back to them to validate that they didn't have any additional need to review or add or based on your exact question. And they came back and said, no, what's in Chapter 6 is acceptable because it's really based on whatever the results are on the actual design. They will meet the ASME code requirements for the pressure boundary.
Well, but I mean, but that's the case for all the components we reviewed, but they made specific presentations on some equipment and some components. I'm assuming that the loads in the reactor coolant system are still bounded by the DCD.
I don't know. I know the supports are bounded.
This is Gina Borsch again from Dominion. So what we did for North Anna 3 was we evaluated the structure, systems, and components that were evaluated in the DCD, and then we had some... Mike wants to go ahead. And then for those areas in the structures, as Lubin was explaining, where we saw some loads that were higher than what was in the DCD, or in certain areas, then we evaluated those further. So we're following the DCD, and as Jim said, we'll have to meet the ASME code, and we'll have to do additional analysis as the detailed design proceeds. Do you want to add?
I think this is Mike Arcure from GE. I think that was the answer that we would give too, is that, the seismic closure plan just looked at those components that were looked at in the DCD. Every component, every seismic Cat 1 component is going to have to meet the seismic criteria for North Anna 3. So this is just a sampling, and I believe that, the vessel was not one of those components that was impacted by this.
Thank you.
And if you look at why we looked at the fuel a little closer because the actual DCD, the technical reports that are referenced, even though the ultimate answer in the technical reports are bounded by what Jim and the staff did, there was exceedances based on what the DCD approved. In other words, in the stresses, for example, on some of the fuel materials. It actually exceeded the DCD, so that's why they wanted to relook at it.
Even though I understand how the loads that get to the fuel have to go through the reaction and how they could go up and not have the load in the reaction coolant system go up. I don't understand.
I think physics comes into play here. This is, the smaller components like the fuel are more likely to see an impact from higher frequency than a reactor vessel. So from a physical standpoint, I wouldn't expect to see a major impact on at least the vessel, the steam generators, the heavier piping, but a more fragile, pardon my use of the word, component like a 12-foot-long fuel rod is going to interact with that seismic signal much differently than a stiff RPD.
When you see video of an earthquake, it's the tomato cans that fall off the shelves to stay. Right?
Thank you.
Mr. Riccardella, I'm Tim Loophole. I'm the branch chief for the mechanical engineering branch, and it was my branch that evaluated the exceedance for the mechanical components. And basically what we did is we ensured that the licensee was still going to meet all the requirements for the ASME code for all the mechanical equipment, and we also have an ITAC then that will go back and verify that this is actually met.
All right, thank you, Tim. So, where are we?
With that, we managed.
We'll finish up, but the SMA update, I have really no new information there other than what Dominion already told you. And all I wanted to say that the retina structures, which are category 2, which are located in the category 2 structures, they are fully qualified for SSC.
I could just add, based on the discussion that with Dominion, was that the reason there's an update in Rev 9 and a confirmatory item because the site-specific DRS and FERS actually applies it. It's 1.67 times the new actual site-specific ground motion, and that's why you end up with a departure of 3.71, which is now confirmed through Rev 9, which was the change essentially for that chapter.
Okay. So I guess we're done with seismic, I think, and we were going to go then cycle back and hear the answers to some of the questions on electrical engineering, on the electrical.
Okay. Do you want us to come up front, or can we do it from here? What would you prefer?
If it's just a short answer, you can do it from there.
I think it'll be short. Okay, so John This-Way has the short answers for electrical first, the questions about control room and the switch yard.
Okay, John, this is Sway from Dominion. So the first question from this morning to get an answer for had to do with how many transmission lines were required to power units 1, 2, and 3, and as I understand it, in a shutdown condition, recovering from and loss of off-site power is where you left it. In that case, it would be 1 500 kV transmission line is suitable for that. The second question had to do with operation of circuit breakers in the 230 kV switch yard. There are no controls in the control room at the bench board that allow you to operate the 230 kV breakers in the 230 kV yard. Those are local operations that electric transmission does in conjunction with operators. Okay, thanks.
And that helps me in terms of knowing what would be in those instrumentation trenches that go out there. Thank you.
Thank you.
Okay, and then John Costello's back to talk about the ETE questions that you had about, well, it was really Dr. Cordini about the 3 inches of ice that happened when he was there.
Okay.
Dr. Cordini, are you still?
Unfortunately, Mike is not on the line any longer, but
Well, how about if we put it in the transcript?
Answer and we'll relay it to him.
Thank you. John Costello with Dominion Emergency Preparedness. So both Bruce Musico with NRC staff and my presentation, there were questions having to do with evacuation time estimates. Mr. Musico mentioned New Reg CR 7002 was the basis for evacuation time estimates, and it established the scenarios that needed to be evaluated. Traffic impediments due to an ice storm that paralyzes the road network, seismic event that might disrupt traffic patterns, or a massive tidal wave that damages the infrastructure were not within the scope of that guidance. So evacuation time estimates are not considered to be a siting criteria. There is no evacuation time estimate that's considered acceptable or unacceptable. The ETE, the evacuation time estimate, is a tool for planners. So protective action guidance is contained in New Reg 0654, FEMA Rep 1, Supplement 3, and it includes consideration of evacuation time estimates. The licensee develops ETEs, updates ETEs decennially, and when population changes cause a significant change in ETE results. Provides ETE results to offsite authorities, submits the ETE to the NRC for review at least 180 days prior to using it in forming protective action recommendations. Offsite authorities use ETEs to develop protective action decision processes, including use of ETE results on a real-time basis when deciding whether to evacuate or to shelter in place, and to develop traffic management strategies such as changing a two-way road into a one-way road with multiple lanes going in one direction. For an agreement between Dominion and the Commonwealth of Virginia, Dominion's protective action recommendation formulation process considers hostile action as an impediment, but nothing else. The Commonwealth's protective action decision-making process considers other impediments: ice, snow, congestion, infrastructure damage, etc. Thus, the Commonwealth of Virginia would consider existing environmental conditions and their effects on evacuation routes before making a protective action decision. In case of a roadway impediment that makes evacuation a greater risk than dose consequences, the Commonwealth has the leeway to order shelter in place in lieu of evacuation. Thank you.
Okay, thank you. So, Jim, we have more staff presentation.
Yeah, well, we can continue with panel 4, and that's with the DCD topics. And we have our panelists, Bob Fitzpatrick, to talk about the single phase, and Dinesh Taneja will talk about, follow up on that instrumentation INC DCD issue that we brought up. With that, we'll start with who's first? INC.
I can shorten. Charlie, turn your mic on. Thank you. You're welcome. I can shorten this a little bit, and you don't have to go through this drill if you want me to. Go right ahead. I went back and found some of my information from back in 2009 and 10. And then I tracked, even though I don't have revision 8, where it was supposed to be reflected subsequent to all the discussions. You remember Skip Butler and all the stuff he did, plus the emails and other stuff they rewrote. So I was able to track that up through into revision 9 and 10. However, there was one part of his presentations, and I'm going to give you will know what I'm talking about. The others won't. There's the inputs. There's the bistable trip unit. I've forgotten what it's called, BTUs or something like that. And then there's a trip logic unit, which feeds an output logic unit, which goes to the actuators. The output logic unit is not a micro